On June 17, 2010, a security firm called VirusBlokAda identified a piece of malware that changed how the world thought about cyber attacks. It didn't steal data. It reached through a computer screen and altered something physical, while making sure nobody watching noticed a thing. The target was Iran's uranium enrichment facility in Natanz. The code moved through Windows machines and Siemens industrial control software until it found the controllers running the centrifuges themselves. Once it had them, it didn't smash anything in one obvious move. It nudged the spin speeds up and down in a slow, deliberate pattern, pushing the machines outside their safe operating range while feeding the control room a recorded loop of normal readings. The operator sat there watching dials that said everything was fine. A few rooms away, equipment was tearing itself apart, and the screen never blinked. The failure wasn't a missing patch or an unlocked door. It was trust. A controller had the authority to change a physical process, and a human being trusted a number on a screen to reflect what was actually happening in the room. And the delivery mechanism made the whole thing worse, because Natanz wasn't even connected to the open internet. The malware got in anyway, carried by hand on infected USB drives using several previously unknown Windows vulnerabilities to jump from machine to machine once it was inside. Reporting at the time linked the operation to a joint American and Israeli program, though neither government has ever officially confirmed it. The gap between what a system was authorized to do and what a human believed it was doing is the real story here. A facility with no internet connection still got compromised, and it worked because the attack fed comfortable lies to the one person who could have stopped it. On December 23, 2015, attackers cut electricity to hundreds of thousands of customers across western Ukraine, hitting 3 regional power distribution companies at once, including Kyiv Oblenergo. And they didn't need a worm or a 0-day to pull it off. They got in with stolen credentials and ordinary remote access tools, worked their way into the utility networks and reached operator workstations directly. From there, they opened circuit breakers themselves by hand, while also jamming phone lines so staff couldn't call each other to figure out what was happening. There's no dramatic autonomous code at the center of this one. Human beings sat at a keyboard and flipped switches that controlled real power to real homes, using access that looked, on paper, completely legitimate. Sit with that for a second. Remote access into these systems isn't a convenience feature anymore. It's an operational control surface. And once someone has it, they don't need to understand the plant. They just need to understand the interface. Before they left, the intruders also deployed a piece of wiper malware called KillDisk, erasing files on the affected machines to slow down recovery. Engineers ended up manually reconnecting substations, and some customers stayed without power for close to 6 hours, while staff drove between sites throwing switches by hand, the way utilities operated before any of this equipment existed in the first place. That was a blackout caused by nothing more exotic than a stolen login and a jammed phone line. Close to 6 hours of manual switching by people doing the job the equipment used to require before any of this was automated. In August 2017, investigators responding to an incident at a petrochemical facility in the Middle East found malware built specifically to target Schneider Electric's Tricon safety systems. Safety systems exist for one job. When a process goes wrong, they're supposed to shut it down before anyone gets hurt. This particular tool, also known as TRISIS, wasn't written to interfere with the plant's ordinary control logic. It was written to interfere with the layer that exists to catch every other failure. That's a different category of risk from a normal breach. The attackers weren't after data. They weren't trying to shut down production for a day. They were reaching for the one system standing between a control error and a physical disaster, and trying to disable it quietly enough that nobody would know it was gone until the moment they needed it. The plant survived, but not because anyone caught the intruders watching. It survived because their own code contained a mistake, and part of the safety system tripped anyway, triggering an unplanned shutdown that brought investigators in to find out why. A bug in the attacker's own tool accidentally activated the exact fail-safe response it was built to prevent, which is the only reason this attack has a name at all. Somebody sat down and decided the safety layer itself was worth attacking, and got caught only because their own weapon didn't work quite as planned. On February 5, 2021, someone remotely accessed a water treatment facility in Oldsmar, Florida, and changed the sodium hydroxide setting from roughly 100 parts per million to 11,100 parts per million. The intruder used ordinary remote desktop software, the same kind of tool plant staff used themselves for legitimate work. To open the control interface and adjust the chemical dosing screen, an operator watched the number jump on his own monitor and reversed it within minutes. Officials later said the change never reached the water supply. There's no exotic exploit in this story. Reporting on the incident pointed to a shared TeamViewer login, the kind of access tool small utilities use so staff can check on a plant without physically driving out to it, sometimes left running on a machine for months without anyone thinking to change the password. Whoever got in didn't need to hack anything in the traditional sense. They needed a login everyone on staff already had, and an interface that let a stranger reach a screen controlling how much lye goes into drinking water. The only thing that stopped it was a person who happened to be looking at the right screen at the right second. A plant this size shouldn't depend on one operator's attention span standing between a keystroke and a public health emergency. And for a few minutes in February 2021, that's exactly what it depended on. In April 2022, researchers at ESET and Ukraine's CERT-UA identified a new strain of malware aimed at high-voltage electrical substations in Ukraine, built during the opening months of Russia's invasion. This wasn't ransomware repurposed for a power grid. It was built from the ground up to speak the exact industrial protocols that substation used, which means the people behind it had already studied that environment in detail before writing a single line of code. It was also a refinement of an older idea. A related tool known as Crash Override had already hit a transmission substation near Kyiv back in 2016, briefly cutting power on its own with no one clicking anything in real time. This newer version picked up that same design 6 years later, in the middle of an active invasion aimed at a live substation while the rest of the country was under fire. It shows what happens once an attacker understands a substation's protocol and its operating pattern. A human doesn't need to sit there flipping switches anymore. The code can do it faster on a schedule, and it can be repackaged for the next substation down the line. The grid didn't need to go dark everywhere for this to matter. A handful of carefully chosen commands aimed at the right point in the system can create a problem far bigger than the number of switches actually touched. None of this stopped in 2022, it just moved into a quieter phase, one where the danger isn't a single dramatic hack but a set of conditions that never quite got fixed. Most industrial environments still run remote access tools with far more privilege than they need, sitting there as an open door for anyone who finds the right login. IT networks and the operational networks that control physical equipment often sit on the same flat network, with nothing meaningful separating them, so a breach that starts in an email inbox can end at a centrifuge or a circuit breaker. Plenty of the controllers running today's plants and grids are decades old, built long before anyone thought to secure them, and many can't be patched at all without replacing hardware that's still doing its job perfectly well otherwise. Safety systems, the layer meant to catch everything else, are frequently reachable through the same ordinary engineering workstations used for daily maintenance, leaving a door in a wall that's supposed to be sealed. And a striking number of operators simply don't have an accurate list of what's connected to their own network, let alone what's quietly reachable from the open internet. None of the fixes here are mysterious, even if they're slow to adopt. Cut off remote access that doesn't need to exist and tightly monitor and log whatever remains. Separate IT and operational networks with real boundaries so a breach in one doesn't automatically hand over the other. Keep safety systems behind independent interlocks with a manual fallback that doesn't depend on any software working correctly. Watch for context, not just intrusions. An unusual set point change, a login at 3 in the morning, a command that's technically valid but makes no sense for what the process is actually doing at that moment. Rotate credentials instead of letting one login sit unchanged for years. And know what's actually plugged into the network before an attacker finds it first, because sooner or later, someone will. A command shouldn't become a physical action just because it passed a technical check. That's the same gap every time, between what a system was authorized to do and what it should actually be allowed to do in that moment. Closing it means every command has to clear identity, authorization, and process context first, and the safety layer has to be the one thing nobody can ever talk their way past, no matter how legitimate their access looks on paper. So, which layer should never be reachable through the ordinary remote session? The controller, the safety system, or a human being's trust in whatever the screen happens to be telling them?